Hi friends, welcome to all. In this session, we are going to hands-on with the multi-area OSPF v2 configuration. This lab will help you understand how to properly configure, verify, and troubleshoot multi-area OSPF v2 in a network environment. So whether you are preparing for a CCNA, CCNP, or just improving your networking skills, this video will give you a clear and practical understanding of how multi-area OSPF works and how to apply it correctly in real networks. Friends, I kindly request you to subscribe to our channel, and if you find the videos helpful, please like and share. Now, first of all, we will design our topology. We need 8 routers. Consider this is R1, R2, R3, R4, R5, R6, R7 and R8. We need switches 2960 series. We'll rename these switches. Coming to connections, in these 3 routers R1, R2 and R3, we will add serial module. Put off this router and add this serial module here. On R2, then on R3. Now we will connect these devices. We will choose a serial from R1 serial 0/2/0, then to R2 serial 0/2/0. Then from R2 serial 0/2/1 to R3 serial 0/2/1. Then choose copper straight through from R2 G 0/0/0 to our switch, then to our router R8 G 0/0/0. Then from R1 G 0/0/0, S1 G 0/1, then G 0/0/1 to S2 G 0/1. The same way from R3. Also, we will connect these routers G 0/2 to R4 G 0/0/0. We can organize these devices. So that we can label area also. Let me label or give some color here for a multi-area. Okay, so this is our area 0. Okay, just I will go to preferences and we'll remove always show port labels in logical workspace. Okay. So this is area 0. This is area 1 and this is area 2. Here in this topology, I will label all the network address we are going to use. So it will be more easy to configure our topology. So here between R1 and R2, we will use 192.168.10.1/30. And here between R2 and R3, we will use 192.168.10.4. Then here between R1 and R4, we will use 10.1.1.0/24. And here between R1 and R5, we will use 10.1.2.0/24. Here between R3 and R6, we will use 192.168.1.0/24. Here. And between R3 and R7, we will use 2.0. Then here between R2 and R8, we will use 10.2.1.0/24. Yes. Okay, just I will keep it here. See, now it is so easy to configure these interfaces in this topology, right? So because we labeled all the networks, now we will configure the interfaces one by one. So as per addressing table, we will configure the interfaces. First of all, we will configure the router R1. CLI. Enable configure terminal host name R1. No IP domain lookup. First of all, we will go to interface G0/0/0 and we will set the IP address as per our addressing table 10.1.1.1. Submit to mask. Activate this interface. Now we'll go to interface G0/0/1. IP address 10.1.2.1. Submit to mask. Activate this interface. Then we will go to interface serial 0/2/0, which is connected to R2. We will set the IP address 192.168.10.1. Then submit to mask. Activate this interface. Next, we will configure R2. No, enable configure terminal hostname R2. No IP domain lookup. We will go to interface G0/0/0. IP address 10.2.1.1. Then submit to mask 255.255.255.0. Activate this interface. Then we'll go to interface serial 0/2/0. IP address 192.168.10.2. Then submit to mask. Activate this interface. Then we will go to interface serial 0/2/1. Then set the IP address 192.168.10.5. Submit to mask. Activate this interface. Next, we will configure R3. Our addressing table is fully ready, so it's very easy to configure the interfaces. Hostname R3. Now IP domain lookup. We will go to interface G0/0/0. Set the IP address 192.168.1.1. Then submit to mask. Activate this interface. Then we will go to interface G0/0/1. IP address 192.168.2.1. Then submit to mask. Activate this interface. Then we will go to interface serial 0/2/1, which is connected to R2. Then set the IP address 192.168.10.6. The other side we configure 10.5. Then submit to mask. Activate this interface. Next, we will configure R4. Hostname R4. We will go to interface G0/0/0. IP address 10.1.1.2. Then submit to mask. Activate this interface. We'll go to R5. Hostname R5. Now IP domain lookup. You will go to interface G0/0/0. Then set the IP address 10.1.2.1. Oh, I need to give the space after IP address here. Okay. Activate this interface. Then we will go to R6. Hostname R6. Interface G0/0/0, and we will set the IP address as per the addressing table 192.168.1.2. Then submit to mask. Activate this interface. Next, we will go to R7. Hostname R7. Now IP domain lookup. Now we will go to interface G0/0/0 and set the IP address 192.168.2.2 with the submit to mask. Activate this interface. And finally we will go to R8. Hostname R8. Interface G0/0/0. IP address 10.2.1.2. Then to mask, activate this interface. Perfect. We configured all the interfaces on all the routers. So for easiness, just I will label the address we used. Here we used 10.2.1.2. Here we used 1.1. Here we used 192.168.10.1. And here we used 10.2. Here we given 10. Here we given 10.5. Here we given 10.6. Here we given 10.1.1.1. Here 1.2. Here 2.1. Then 2.2. Here we given 192.168.1.1. Here 1.2. Here 2.1. And here we given 2.2. Next, we are going to configure multi-area OSPF. So here we can see this R8 and R2 is in area 0. Then here we can see R4, R5. Then R1 interface G000 and G001 in area 1. And this interface R1 serial 0/2/0 in area 0. Then on R3 G0/0/0 and G0/0/1 are in area 2. Then on R3 serial 0/2/1 in area 0. So we will configure multi-area OSPF now. First of all, we will configure on R8. Router OSPF, we will choose process ID as 1. We will set the router ID. So we will give the ID as per this host name number R8. We will give 8.8.8.8. Now we need to give the network address, directly connected network address, that is 10.2.1.0/24. So network is 10.2.1.0. We need to give the wildcard mask 0.0.0.255. This is in area 0. Next, we will go to R2, and here we can see all the interfaces are in area 0. Router OSPF1, router ID 2.2.2.2. Now we will give the network address. Here we can see 3 directly connected networks. Network 192.168.10.0. Then wildcard mask 0.0.0.3. This is in area 0. Then network 192.168.10.4 between router 2 and router 3. Wildcard mask 0.0.0.3. Area 0. Then we got network between R2 and R8. That is a 10.2.1.0. Wildcard mask is 0.0.0.255. Area is 0. Next, we are going to configure R1. you can see these two interfaces, that is G0/0/0 and G0/0/1 are in area 1, and this serial 0/2/0 is in area 0. So we need to configure according to that. Coming to R1, first of all we will configure those interfaces which are in area 1. So router OSPF1, you will set the router ID. This is R1, so we will give a 1.1.1.1. So first of all we will give the network 10.1.1.0, which is connected to R4, I mean the network between R1 and R4, which is in area 1. Wildcard mask is 0.0.0.255. Area is 1. Then network between R1 and R5, that is a 10.1.2.0. Then wildcard mask 0.0.0.255. This is also in area 1. Then we will give a network 192.168.10.0, the network between R1 and R2. Wildcard mask is 0.0.0.3, and keep in mind this area is 0. Then next we will configure R4 and R5 interface G0/0/0 on both routers R4 and R5. They are in area 1. So we'll go to R4. Router OSPF1, router ID. So this is a router 4. We will give a 4.4.4.4. Network. So the network address between R4 and R1, that is 10.1.1.0. Wildcard mask 0.0.0.255. See, area is 1. Copy, run space, start. Then we will go to R5. Router OSPF1, router ID, you will give a 5.5.5.5. Network, the network between R5 and R1, that is 10.1.2.0. Then wildcard mask 0.0.0.255. Keep in mind area is 1. Now we will configure on R3. So here we can see interfaces G0/0/0 and G0/0/1 are in area 2, and serial 0/2/1 is in area 0. So we need to configure according to that. Coming to R3. Router OSPF1, router ID 3.3.3.3. Network, first of all we will give a 192.168.1.0. then wildcard mask 0.0.0.255. This is in area 2. So then we given the network between R3 and R6. Then a network 192.168.2.0, the network between R3 and R7, and wildcard mask 0.0.0.255, area 2. Next we are going to give the network 192.168.10.4, the network between R3 and R2. Then wildcard mask 0.0.0.3. This is in area 0. and next we will go to R6 and R7. Router OSPF1, router ID 6.6.6.6. Then we will give the network 192.168.1.0, the network between R6 and R3. Then wildcard mask 0.0.0.255. So this is in area 2. And then we will go to R7. We'll give a router OSPF1, router ID 7.7.7.7. A network, that is network between R7 and R3, 192.168.2.0, then wildcard mask 0.0.0.255. Area 1, sorry, area 2, yes. Copy, run, space, start. Now we will verify our OSPF configuration. We will check our routing table. Coming to R8. Show IP route. So here we can see all the remote networks. Okay. Coming to R2. Okay. Coming to R1. Oh, here we are getting a duplicate address. Oh, we configured same address on R1 and R5. Okay, we will reassign that. Duplicate address 10.1.2.1 on gigabit Ethernet 0/0/1 sourced by this MAC address. Okay, so let me verify the address we given here. It's 2 dot. Let me go to R5. Okay, show IP interface brief. So we'll troubleshoot it, and here we can see we given the same IP address what we given here on R1 G0/0/1. So I need to change this address here on R5. Interface G0/0/0 will reassign the IP address one. It's 10.1.2.2 255.255.255.0. Okay, so we'll correct it. And copy, run, space, start. Okay, now we will verify the IP address. Show IP interface brief. Okay, that's correct. Also, we will verify the addressing table. Show IP route. Yeah, that's fine. 10.2.192.168.10 and 10.4. Okay. And it should learn about this network also 192.168.1.0 and 2.0. It's not there in the entry. We will just fast forward because so that the network should this topology should fully converged. So we'll go to R4 and we will verify the routing table. Show IP route. Okay, here we can see all the inter area OSPF. There are 5 inter-area OSPF. Okay, now it's added. Again, we'll verify here. Yes, so there are 5 inter-area OSPF. It's correct. We'll verify on R3. Show IP route. So here we can see 10.1.1.0, 10.1.2.0. We can verify on R6 and R7. Show IP route. Okay, we can see all the remote networks learned with the help of OSPF. Also, we can see this inter-area OSPF. There are 5 inter-area OSPF. That's correct. So we'll go to R7 also. Show IP route. Okay, that's correct. Even we can test the connectivity between any routers. It should succeed. Perfect. We can test from any router to any router. This is the same topology we have seen with the packet tracer activity. I think it's 9.2.1. So same design, but there they added the cluster like this. Just I will show that here. So this is area 2. Just I will remove this address here. Then here, this is area 0. Sorry, this is area 1, right? Yes. Area 1. So just I will remove all this. Area 0. Correct. So just I will remove all this. So this is the topology we have seen there. Friends, I hope this hands-on demo helped you understand how to configure and verify multi-area OSPF v2 clearly. If you found this useful, don't forget to like, share and subscribe to the channel for more practical CCNA and networking tutorials. Also, feel free to comment below if you have any doubts. Thank you for watching. See you in the next video. Keep learning and keep practicing.